Alright, this is going to be our last lesson for the chapter, so we're going to start reviewing tomorrow.
Yay!
Yeah.
Oh, done?
And it's not a super long chapter, so make sure your
I hate
headphones are
graphing.
put away, make sure you're not on YouTube or anything. Take your
I'm
time.
just gonna sit like damn all of
Oh, damn.
Oh, and you will actually need Desmos on your Chromebook, so make sure you got Desmos.
Need it.
But then close it so we need it.
Louis, who'd win, Jam Fam or Jelly Fam?
Neither, because nobody's paying attention. Alright, so we are doing our last lesson. This is over exponential functions. So, an exponential function, if it's graphed, looks like y equals a times b to the x. And a and b are real numbers. And, A and b are real numbers. The reason this is different is because my exponent is x right here. So before, we've had x's and stuff before, but this is the first time we've looked at it where x is the exponent. And so they look a little different. So these are some examples of exponential functions. Exponential functions, when they're graphed, they tend to be like nothing, nothing, nothing as you graph them. You got nothing, 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 and then all of a sudden they go way up really quick, or nothing, 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 way down really quick. And you can flip them around the other way like you see right here. But it's generally nothing, nothing, then all of a sudden it just shoots up, or just plummets down. So that's what makes exponential functions kind of unique. You actually will use exponential functions a lot in your life. A lot of times, if you have a bank account, or when you get older and you get a bank account, a lot of times the interest you earn in bank accounts are based on an exponential function. There's a couple different kinds, but we'll actually do some of those in algebra too. You can see like how much money you would make if you were saving in a certain bank account. So these are actually pretty relevant. You see these around in a lot of business type situations. So we're going to start off by looking at a table and saying, is it an exponential function, yes or no? And we've done something similar to this. We did something similar when we said, is it linear, yes or no? This time we're going to say, is it exponential, yes or no? And kind of like in linear, we need two things. We need to look at x's, we need to look at y's. X must change by the same amount as a plus or minus to start with. That's usually the easy part. So last time we really had it change by 1. This time it can change by whatever as long as it's the same. So on my x's up here, 0 to 1 is plus 1, 1 to 2 is plus 1, 2 to 3 is plus 1, that kind of thing. Where it gets interesting is with y. If it's exponential, y must also change by the same amount, but this time it's got to be a multiply or divide by the same amount. So in linear, it was plus or minus. In exponential, it's got to multiply or divide by the same. So let's look at this one. If I'm going from 1 to negative 3, what can I multiply by or divide by to go from 1 to negative 3? 3, right? Times 3. What about going from negative 3 to negative 9? What can I multiply by? Times 3. And negative 9, negative 27, times 3 again. So times 3, times 3, times 3, same times.
Penny.
So yes, this is exponential.
What do you want, James?
Because we multiply by the same amount. What's up, Dan? Amy?
Oh, how many people do you have in your Algebra 1 class?
Really?
Doesn't matter.
Yeah, it does. Well, that's what's in there. It's like
Algebra
bad
1.
grade
In this
freshman
class
year.
right now?
What?
This is algebra 1.
How many seats was that? 1?
Like 4. Yeah.
Okay, well, I might switch in here.
Please don't.
You don't
Yeah,
have
we have
We
enough.
don't want you in here.
Wait, what are you going to do?
Maybe like our all
Alright, yeah, we got 14 out of like 18.
We do not.
really do that?
And you guys are annoying enough as it is. Annoying in here too.
Yes, we do not need James in here. I know.
Oh well, we'll deal with it.
Whatever
No.
Alright, finish.
Loki, make him go on one end. Make him go on one
Let him
end.
sit by Beto.
No.
Major.
No.
Alright, just we're gonna keep going. We're just starting now. Okay, so we're just going to these tables. Say, is it exponential? Yes or no. We need to make sure x goes by the same plus or minus, and that's all plus 1. That part's easy.
Okay,
Alright. Yes. Alright, on this one, go from negative 1 to 1. What can I multiply or divide by? Go from negative 1 to 1. Yeah, I could times negative 1, right?
Yeah.
We're going through it though. How about going from 1 to 3? What can I multiply or divide by? Are these two numbers the same?
No.
So, as soon as we get one that's different, I can say no, not exponential.
Different.
It's pretty much.
And I usually abbreviate exponential as EXP.
I usually
For exponential.
Experience.
That guy's gonna be
Am I gonna get it right?
As long as I know you need it.
If I go equal.
Psych.
Alright, do part B on your own real quick. Say, is it exponential? Yes or no?
Yeah. No. Yeah.
So part B, is it exponential? Yes or no? And we'll have somebody help us out real quick.
Yeah.
I'm good.
Can I get it right?
Oh.
Bro,
What up?
you know, the back what you got that's what I'm
Alright, let's go through this. Gabe, what are my x's changed by each time?
2.
Okay.
My x's?
Oh, 1.
Yeah. Or plus 1.
Oh,
Ew.
by like.
Yeah, x's changed by each time. Alright. And then if we're going to look at our y's, Luis, do our y's change by the same amount each time?
Yeah.
What are they changed by?
Dos.
Multiplied by. Multiplied by. Yep, these all change by a times 2, which means, yes, it's exponential. So not too bad for that part. Yep. So, we are also going to graph some exponential functions. And they're not super tough. You guys have done really, really similar things before. But this time around, we're going to use Desmos to help us out a little bit. So we are going to graph y equals 3 times 2 to the x. So we're going to pick some x's to plug in. We're going to pick some x's to plug in. And I will let you choose whatever x's you want, as long as, hey, hush, we're still working on
Hush,
this.
guys,
Be
please.
quiet, please.
I will take away headphones again,
Yeah,
like
you will.
yesterday.
Okay, no.
Hope
Oh,
you guys
wait,
aren't
take
helping.
away music?
Yeah,
That's it?
like yesterday.
No.
Shut up, Ruben.
That's it?
Shut up. Where's your bag?
Or start giving out detentions if you want. I don't like doing it, but I will.
That's it?
Okay, so we are going to pick some x's to put in. You can pick whatever x's you want, but for exponential, you really don't want super big x's. Because if you plug in, say, 10, you might get the number like 1,000. Because exponential, it jumps up really quick. So you want to get things that are kind of close to 0. So I'm going to go negative 1, 0, 1, and 2. We're going to plug those in. So what we're going to do is we're actually going to use Desmos to make a table. So I'm going to make a table for 3 times 2 to the x, and instead of, so we've done this before where we did this individually. So just as a quick example of what you guys did before, we would plug in negative 1 for x up there, 3 times 2 to the negative 1, we plug it into Desmos and see what we get. And then we do the same thing, but this time plug in 0, 3 times 2 to the 0, see what you get. I'm showing you guys a shortcut this time.
That would be 3.
So, on Desmos, and I want everybody to do this to make sure everybody can get it.
Why?
No, I guess I closed Desmos, hang on.
So for the x, we're just putting in our own number?
Yes, you can choose whatever x's you want, but you really don't want x's very far from 0, because it
So
gets
we
really
could do
big
0.
really quick. You could do 0, that's fine. So I'm doing negative 1, 0, 1, 2. And let me get Desmos going here. Alright, here we go. Alright, in Desmos, what I want you to do is click on this plus sign, and then go table. And it's going to look about like this.
Are you kidding me?
So your dot right here is going to be a different color, but that's not a big deal.
Okay, how do I do that?
Click on the plus sign, and then click on table. And then, what we're going to do, this, even though the table takes a little bit of time at first, after we set up the first one, we can just change like one thing on every other problem, and it's really quick after the first time we do it. So, it says x1 and y1, and your dot's a different color probably, but that doesn't matter. So, what I want you to do is delete this 1 by x1. Delete that 1, so it should just be x. Because
And the
you
Y.
can do different x's, but we don't really need to. So just delete the 1 by x.
Can if I want it.
And then, no, because if you don't do it, it'll be wrong. Like, it won't actually work. Over here on y1, I want you to delete that. And we are going to type in this 3 times 2 to the x, because that's what we're graphing. We're not going to type in the y equals. We're just going to type in 3 times 2 to the x right here. We go back to Desmos.
Okay, I got a question.
So 3 times 2, yeah, maybe.
Why is yours green and mine orange?
It doesn't matter, it just picks a random color.
Wow. That's all weird.
Okay, so because we are not doing the squared, this A squared button is your squared. Because it's not squared, you do this AB button to do your exponent, and then you type in x for this one.
That's radical.
Okay, then we are almost done. We just need to fill in the x's that we're plugging in. So I am doing -1, 0, 1, and 2. This is my table right here. So I plug in -1 for x, and I get 1.5. I plug in 0, I get 3. Plug in 1, I get 6. I plug in 2, I get 12. And just for fun, just so you guys can see what it looks like when you plug in other numbers, if I plug in the number 5, I get 96. Which is really annoying to graph up that high. You gotta make your y's go by like 10s, and it's annoying. So when you guys pick your numbers, when you pick your numbers for your table, keep it close to 0. And just for fun, if I plugged in
Let me go up real quick.
if I plugged in 15, I would get 98,000. So that's how exponential works. It's really big, really quick. Alright, so let me go back to my table. 1.53612. So I had 1.53612. That wasn't a negative, was it?
No.
So I am going to graph these, then I'm going to need to connect my dots so it's an actual graph, and then that'll be it. So I have -1, 1.5. Left 1 up to 1.5, put a dot. You're going to estimate that, it's fine. I have 0, 3, means I'm going left and right 0. Then up 1, 2, 3. I have 1, 6. I'm going right 1, up 4, 5, 6. And then I got 2, 12, right 2, up 7, 8, 9, 10, 11, 12. And our dots are going to look like this. Okay, we are not quite done. We just have to connect our dots. But keep in mind, exponential, they are really flat, and then all of a sudden they jump way up, which you can see. It's kind of up, then even more up, then way far up. So when I make my graph, I'm going to connect my dots. And over here at my last dot, I'm not going to go down like this, even though that's kind of the direction it's going. Because it's exponential, it kind of evens out. So I'm just going to go about like that instead. Because it gets flat, it starts off going really flat, and then it jumps way up or drops way down. So don't just make it like a straight line like this. Level it out. Level it out. Okay. We're going to do practice one more, but it's going to go even quicker because unless you deleted stuff in Desmos, it'll be way quick to do the next one. Question, Beto? Yeah, question? The Desmos thing? I'll help you in a second. Okay. We are going to do 0.5 times 3 to the x. So, I'll help you in a minute, Beto, but we're going to plug in, I'm going to do -1, 0, 1, and 2 before. And in Desmos, the only thing I'm going to change in Desmos is that, you know where we deleted a y1?
Oh, yeah.
I am just going to delete what's there and just put this piece in. Because I'm using the same x's as before, so all I need to do is change this right piece. So I'm going to go 0.5 times 3 to the x in Desmos, right here. Let me delete this and go 0.5 times 3 to the x. Because after I do that, and actually let me delete these extras that I don't need anymore.
That's pretty good.
After I do that, my table's already set up. This is already x. This is already the -1, 0, 1, 2. I just changed this, and I have everything I need right here. So when I plug in -1, I get let's round it, 0.17. 0 is 0.5. 1 is 1.5. 2 is 4.5. So So let me go back to my table. 0.17, 0.5, I can't remember 4 numbers apparently. 1.5, 4.5. Excuse me. Alright, so we have our table, we're going to graph it. Negative 1.17 is going to be just barely above the line, so we're going to estimate it. 0.5, left and right 0, up about halfway between the line. Yeah, good enough. 1.5, right 1, up 1.5. And then 2, 4.5. 1, 2, 3, 4.5. This one's a little easier to see how much bigger it gets all of a sudden. And then we're going to have to graph this, but we got to keep in mind exponentials start off really flat and then jump way up. So on this part over here on the left, I'm going to start off going pretty much flat, and then I'm going to jump way up. Like that. Alright, next day class problem. I want you to make a table and graph part B. Just put it on the same graph right here. So make a table, graph part B. If you're not sure how to do the Desmos piece, I will go around and help you real quick. So let me help you on that, Beto.
Do we use this little table here?
Yep. Alright. So do your table. Look at this plus 1. And then you need table. Delete this 1 by x. And then go right.
Yeah.
Delete.
So we can just do it like this.
Delete that and type in the piece absolute, which is negative 0.5.
Yes. Because these two, exactly the same, except that's negative. So we go like this.
Yeah.
3
No, it goes down the other way.
to the there. Okay.
Hold on. Let me draw the
And
lines.
then in here you put in x's you pick. I'll let you pick whatever you want, but keep them close to 0.
It goes like that.
There you go.
Oh, yeah.
So 0 and 1.5. 1, 0. And then you can graph your table.
How do we do
First,
this?
copy the table right here. And then graph it.
Yeah, copy it here.
I try to do that.
Delete y1 right there. And instead of y1, the whole thing, y. Type in this part after the equal sign. Negative 0.5 times the 2d. There's an AD button there.
Set up the Desmos thing.
Alright, so you hang it on 0, do 2 more. Like that. Alright, there you go. That's the table. Now you can grab it. But
I know.
what's wrong? Am I ready? Actually, wait.
Yeah, with the
It's
side.
negative, it's -1, right?
Oh, I
So
did
you went over 2.
It?
Oh.
I'll just ask.
What?
But-
How do we
What's your first point?
Okay. Think I finished.
Negative 1,
That was
point, negative 0.16, right?
Okay.
So negative 1, then you're going to go up just barely down. So that's 1. So that's 1. Zero, then down,
When I get tired, I don't go.
Oh. Javon, but you know who Javon
Why would it be go right? Why would it go right?
because it's a positive 1. So you start
Oh,
with
I see.
Alright, these are looking pretty good. You know what? We're not going to go over it because I haven't seen anybody get it wrong yet.
Oh,
Except Adelia, who accidentally went over 2. So
Where?
that's no big.
You guys see James Harden 60-point triple double?
Alright, so we're going to do one last thing. one last type of thing. We're gonna look at story problems. Oh, the funnest thing ever. All right, and like I told you before, exponential functions show up in a lot of different places. So, in business or like in banks, you use them a lot. You also do them a lot for like different like things in nature tend to be exponential functions. So, let's look at this one right here. Ashlyn, read this problem for us.
No.
Yeah, how'd you get from talking? More talking.
Okay, wait. 34.
Read the story problem.
Out loud.
No.
Not to yourself, out loud.
Oh my.
Population growth
34 people.
for the whole class here.
Why do I have to?
Because you
We're
were talking.
talking.
No, it was talking.
No, so you can do the next one.
Wait, was 34
Hurry
people
up,
for
read.
work
Hush.
read already in a warehouse has been the beetle population doubles each week. The
I'll just
Hush.
I'll do something.
We can't even hear what you're
equals 30
saying.
Hush.
times
Don't talk over
2x gives the population after x weeks. How many beetles will there be after 56 days?
A lot. A little modelly, but I'll take it. Alright. So, this is looking at a warehouse with these beetles inside this warehouse. And they figured out that the population of beetles works with this equation. F of x equals 30 times 2 to the x. Remember, we've done f of x before a little bit. It's a function, it's just a fancy y. So it says f of x equals 30 times 2 to the x. They want to know how many, and then it's the population after x weeks. They want to know how many beetles will there be
30.
after 56 days.
I don't know how many types
So,
of
You put 30. You put 30.
Psych.
After 56 days is what they want to know. Alright, so we're going to have to plug in something to this x, and then we're just going to have to evaluate it. But let's look at it real quick. What does x represent in this formula?
number of weeks.
Is 56 days a week?
No.
No.
No. How many weeks are in 56 days?
A lot.
Not that many.
8.
How many days are in a week?
7 is 8.
So there are 8 weeks.
Yeah.
If there's 56 days, 7 days in a week, 56 divided by 7 equals 8. So you gotta watch out, it's a little
So,
sneaky.
There we go. 8 weeks.
So, we are going to say 8 equals x. And all we need to do is take this 8 for x and plug it in right here. Even though it's a story problem, it's really not that intense.
So
don't
instead of
freak
an
out about
x, it would be an 8?
it. So it'll be an 8. So, I am plugging in 8 for my x. So I'm going to say f of 8 equals, remember, this is a function. Whatever number we plug in for x, we write here in the parentheses. So I'm going to say f of 8 equals 3 times 2 to the 8.
30.
What?
Yeah, it's 30, not 3.
Oh, alright, sure, it's on there. 30. I didn't hear you.
Okay.
30 times 2 to the x.
What the heck?
I thought that seemed like a weird formula, but if you start with 30 beetles, why are you starting with 3? But oh well. Anyway, so that was 30 times 2 to the x, not 3. Alright, all I need to do is just plug this piece right here into Desmos. 30 times 2 to the 8. So we grab Desmos, and go down here to this next line. 30 times 2 to the 8. 7,680.
Oh,
7,680. So, after 56 days, or 8 weeks, there will be 7,680. And what does this 7,680 represent?
Beetles.
Beetles. So, when it's a story problem, you gotta make sure you label it. No, I'll write beetles. So, this is an example of how you use exponential functions. A lot of things like this. So 7,680 beetles after 8 weeks. Alright, I'm going to have you guys try one.
Dang it.
Because it's really not that intense, you just gotta plug a number into the equation it gives. But before we get started, Adelia, read this for us.
Okay.
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 Hush, let her read.
An additional population of 20 rabbits triples every half. Here, the function fx equals 20 times 3x gives a population after x half-year periods. How many rabbits will be there after 3 years?
All right. So on your own, you figure out how many rabbits will be there after 3 years.
That's what?
You're gonna use your formula. For 20 times 3.
Do this.
You gotta figure out what to put in for x.
When we divide this by 6,
Sorry.
What is x? What is x?
Okay, so there's
So
20
it's not
rabbits
weeks. X is
every
a week.
half year,
Periods.
triples.
How many half-year periods are in 1 year?
Function, so you write the function down, there's a
Two.
population of x equals
So
half
if
year.
it's 2
How
half-year
many
periods
half
a
year
year,
after 3 years?
how many are in 3 years?
So all you're figuring out is what x is. So x is half year periods, and if there's 3 years, you would put 3 into 2.
themselves, Lily. Doing them answers.
Oh,
I'm
damn,
not getting them
I was right. I was
open.
right.
Make it work for this, or at least have them pay you. I can buy you some Cheetos or something.
I don't have any money, Mr. Golkey.
Why did you make a huge table?
Mr. Golkey.
Well, you didn't
Get
go far
6
enough
from-
because
Because x equals
After
half
3 years,
a
right?
year,
But what does x equal?
and there's 3 years.
In the formula, what does x represent? Half-year periods, right? How many half-year periods are in 1 year?
You mean 2, there's 2.
No. How many half-year periods are
Because
in
when
1
you
year?
cut things in half, there's 2
Look
of
at
them.
this. How many half-year periods are in 1 year?
Like if I were to break this into half, then there's 2 pieces.
How long is half a year?
No, just kidding. Put it back together.
Yeah. Right, 6 months and half a year, right? If you go 6 months
but
and
do you
6 months,
understand that?
that's 1 year, right?
Yeah.
So there's 2 half-year periods in 1 year.
What part of it?
Okay. X is half-year periods. How many half-year
Yeah,
periods?
well, if you just, well, what'd you get? 14,500.
No, wait, what? Okay, so there's half year.
There's
And then,
2 half-year periods in 1 year. How many are in 2 years?
wait,
14,500.
Wait, so there's 2?
2 in 1 year, right? Okay. How many are you gonna have in 2 years?
79.
How many are you gonna have in 3 years?
You just 20 times.
7.5.
You only plug in the second half.
oh,
X is
so this part doesn't matter.
So all you need to do is put in x.
So,
And then 6.
oh, that would be,
Where, right here?
Well, in, like, on your table, go to the bottom and type in x.
Oh, well, that's
You know how Mr. Dragon today?
It's there, I just didn't have the space for it.
I think I got the hang of it, Mr. Golkey.
I used to put X in there.
Oh, that should be an x right
Oh.
Good thing it
Type it in.
It's rabbits, right? That's why it's
You should run the code.
Alright, let's start going over this one.
I'll do this one on the white.
Let's start going over this one. So, we want to know how many rabbits will be there after 3 years. So, help me out on this first one, Luis. What does x represent in here? Not what are you going to plug in for x? What does x represent?
I'll see what you're asking.
Half-year period.
What does x
Oh,
represent?
half a year.
Half year, right?
Yeah.
And it wants to know how many are there going to be after 3 years. So, if x is half years, how many half years are in 3 years? Okay. So we're going to plug in 6 for x and solve it. So f of 6 is going to equal 20 times 3 to the 6. And what'd you get for your answer? I'm not going to do Luis again because I just did it. Beto, what'd you get for this one? Sorry, say that a little louder.
14,580.
Thank you. 14,580. And we can't forget, we got to label this because it's a story problem. Magi, what label are we putting on here?
Rabbits.
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 And them little buggy.
Rabbits. Little rapscallions. rabbits. All right. So we did 3 things today. We looked at the table, said, is it exponential? Yes or no. We graphed them, and we did a few story problems, which really aren't all that intense. All right, your exit ticket isn't on there because I didn't have space. This is your exit ticket. For the exit ticket, it's basically what we just did, but instead of giving you a story problem, it just wants you to plug it in.
Okay.
So, on this one, you're going to calculate, let me make it a little bigger, so it's easier to see because I didn't print it. For problem 1, you're going to calculate 6 times 2 to the x when x equals 3. So you're going to plug in 3 for x and plug that into decimals. So, it's like that. And I don't know if we talked about this yet. G of x is still a function, even though normally we use f, but g of x is a function, or g of w is a function. It's kind of like normally we use x for a variable, but sometimes we use y, same thing. Normally we use f, but sometimes we use g. So keep that in mind.
Me and Robert are the buffaloes.
Alright, so work on this on your paper. I will get Socratic figured out and get you the right one this time.
I like the